Welcome to The Mystic and the Skeptic, the show that asks the tough questions and explores different alternatives to today's pressing issues, theories, or enigmas.
A podcast devoted to the exploration of all things mystical, philosophical, scientific, political, conspiratorial, and cosmic. Join us in an exploration of the Mystic-Skeptic mindspace.
In this week's show, we are discussing the Flat Earth conspiracy theory with three different guests. Theo Wellington, president of the Barnard Seifert Astronomical Society, theologian Michael Heiser, skeptic scientific researcher Brian Dunning. Most of the conversation will be with Ms. Wellington, but we will air a couple of the short interviews with the other two guests as well. When it comes down to conspiracy theories, there is nothing better than having a minister and two scientists to debunk the outrageous claims of the Flat Earth conspiracists. For those unfamiliar with the controversy, in the past couple of years, religious and secular individuals who believe the Earth is flat have resurfaced in the age of the Internet. We are not speaking about the discredited Flat Earth Society. They were the ones who popularized fabrications of a conspiracy orchestrated by NASA and other government agencies. The Flat Earth belief came to the forefront in 2015 as media personalities used Twitter to proclaim the Earth is flat. Theologian Michael Heiser.
I wrote a post called "Christians Who Believe that the Earth is really flat, can it get any dumber than this?" And that's produced almost 120 comments, and a lot of them are really angry.
So you actually know some people who feel that way?
Oh, yeah. Yeah, I do now. I posted it because, I've written some articles on Israelite cosmology, that it's, consistent with any other ancient Near Eastern cosmology. You get a round, flat Earth covered with a dome, the pillars of the Earth, pillars under the Earth, all the typical vocabulary and the imagery, dotted throughout the Bible. And my basic point is, hey, this, if you're going to embrace inspiration, then God knew what He was getting when He went to somebody in the second millennium BC and prompted them to write something. That they didn't have this scientific knowledge, so it's understandable then. But to believe in the flat Earth now, and somehow say that, this is what we're supposed to believe, because of the Bible is just absurd. And because of that, I've been getting emails and things on Facebook. Do you really believe in the flat Earth? And I've gotten enough of these that I don't know what was going on out there in Facebook land. But I posted this, and lots of people have been real angry about it. And it's depressing actually. But what can you do?
But do you see it as any publicity is good publicity?
I see it as any annoyance is a real annoyance.
No, definitely. But I can tell from your background and what I've read about you online is that you're trying to shed light on how scholarship is important when we're talking about important issues, especially dealing with the Bible. If a debate is started regarding that issue, then people will be more aware of how you can still have very strong held beliefs, but also integrate academic and scholarship knowledge into the mix and still come out sane. Do you think that can be true?
Well, it can certainly be true, but thank you for trying to cheer me up there. For a lot of these people, at least from the tone of the comments, I just think that, once you've sort of given yourself over to dispensing with reason and I think this is the bigger problem, having such a deep distrust of science, the scientific community, and really going off the deep end on the conspiratorial way of viewing the world, that you're sort of immune to appeals to reason. It's probably a bit of an overstatement, but I don't know what you can. You can tell people the truth, and that's just what we try to do, and sort of leave it at that. But some of them just really get hysterical about it. I mean, I found it, I can't believe that my background would be so different. But when I was in grad school, I mean, the church I went to, this was a serious church, but it was dominated by people in the hard sciences. I mean, we had a dozen faculty members from the University of Wisconsin there, and heads of departments, all sorts of things. I mean, I was in the humanities and I felt alone, it just, they were serious scholars and serious scientists, probably a better way to put that, but also, serious believers. And it was just a really good thing to see. It just makes me laugh whenever I hear people, from the atheist community say something like, well, you can't be a real scientist and, be a Christian or, believe in God. It's just a joke. I mean, you have to want to believe that. That is a belief statement right there. And it either shows that you're underexposed to reality or you're just willfully suppressing some point of reality that you don't want to entertain. And I think the flat earth is sort of the flip side of that coin. Just somebody so giving themselves to some position or idea that you almost can't appeal to them. But with what I do, it's like look, to someone who criticizes the Bible over science, I mean, it's like, why are you criticizing this book, for not being what it was never intended to be? Are you mad at your dog for not being a cat? Are you mad at your daughter for not being a son? It's just, it doesn't make any sense for you to criticize something for not being what it was never supposed to be. That's just incoherent. So we can have a discussion if you can demonstrate to me that this approach you have makes any sense at all. I mean, that it isn't absurd. Because if you can't do that, I mean, that criticism sounds really dumb to my ear. But people, it's uber literalism. It's this myth of, we can't assign importance to the Bible unless we approach everything with just some cartoonish literalism, and it's any number of things.
Skeptic scientific researcher Brian Dunning.
The episode I did of my show this week or last week was on the new flat Earth people, because I did an episode a couple of years ago about the old flat Earth belief from the 18th and 19th century, early 20th century, which was largely Christian fundamentalists trying to prove the literal truth of the Bible, and they somehow believe the Bible thinks the world is flat. And today, though, the new flat Earth people are basically just conspiracy theorists. They're people who are attracted by the whole idea of there are powerful overlords who are actively pulling the wool over our eyes, and the conspiracy theorists always believe that they alone are the ones who are enlightened enough to see through this giant scam that's being pulled over the eyes of the whole rest of the world. And that's what the whole new flat Earth movement, when you look at today's flat Earth forums, they're busier than ever, but it's wrapping up flat Earth belief with 9/11 conspiracy theories, New World Order, everything else. And it always blames the Jews, the Jesuits, the Masons, the whole group you just listed. It's just any group who people tend to believe are powerful and in control, they tend to want to assign evil intentions to them.
I know it's off topic, but is the flat earth people related to the fake moon or whatever else they're talking about, the moon being like a satellite or something?
It's a whole kind of culture of alternate science. Any science that we've been taught is perceived to be part of this whole sham, that the New World Order, for whatever reason, which I've never found a good explanation for, wants everyone to believe some wrong version of science. So, yeah, you'll see every different version of alternate moon sciences. It's never just one, and there's different models for the flat Earth. Is it flat that's rotating like a record? Is it constant and the sun is going around it? Is it constant and the sun is orbiting in a circle above it? There's all these different models. Even though they're fundamentally at odds with each other, they're still united. They still consider themselves allies and friends, in that they don't know what model of the flat Earth is true. They don't even care. They just care that whatever they've been taught is wrong. That's the only thing that's important. And as long as they can agree on that, they're all happy. Yeah, there's been a couple of Skeptoid episodes where dealing with popular creationist beliefs and what the science-based response is to each of the claims.
Our main guest, Theo Wellington, is a graduate from Case Western Reserve University with a Bachelor of Science in Astronomy. She joined the Barnard-Seifert Astronomical Society in 2003. She worked at the Sedgwick Planetarium for 11 years and is a volunteer with the NASA JPL Solar System Ambassador Program. She lives in Goodlettsville, north of Nashville. Welcome to the show. Please tell us about the Astronomical Society you're part of and what got you interested in astronomy to begin with.
The Astronomical Society is actually a group that's been around for a number of decades. It's just a group of people that are enthusiastic about the night sky. Some are astronomers, some are dentists and plumbers, so they come from all walks of life. They simply share a love and interest in the night sky, space, rockets, sort of anything that has to do with space. So some members just join to get information. I have maybe a core of 10 people who do monthly star parties where we go out to parks, set up telescopes, and let everybody look.
How about you? How did you get interested in astronomy? And if you have a bachelor's in astronomy, does that make you an astronomer, or do you have to have a doctorate?
You really need to have a doctorate in order to actually work in the field. I've been really blessed that over the last 11 years or so, I was able to use a lot of what I know and enjoy and to communicate that with others at the planetarium. Mostly I did school groups that would come for field trips, and so introducing them to the night sky and ideas about the planets and what we know. I probably got started the way a lot of folks of my generation did, which is we were going into space. It was the space age. It was very exciting. I was 9 years old when we landed on the moon, so that kind of got me interested in space, but then I actually fell into the science part of it where I got extremely interested in how much information you can get just from observing, faint beams of starlight.
And that's allegedly landed on the moon.
Well, like I said earlier, you can see the footprints now. I fully expect that, kids being born now will probably get to go and actually stand there and look at them, but we'll have to wait on that.
In our previous conversation, as we were getting ready for the show, we talked about how if people decide to believe something, there's really nothing you can do to convince them otherwise. But we're going to try to at least share some of the knowledge that is available out there regarding the Earth being circular. I've heard them say that the Earth is actually not a sphere, according to scientists, but it's more like an egg. And when you look at pictures, it looks more like a sphere. So that right there contradicts itself. And then they think it's like a record that just sits flat, and the Antarctica is all around it. So you sent me some information about how just the issue of the distance between the Earth and the Sun can be determined using an app on an iPhone. Can you elaborate on that?
Sure. The way we ourselves determine distances to things is that we have two eyes that are offset by each other, and so the image that the eyes see is not the same. There's an angle difference, and if you put your thumb out in front of you, close one eye, and then switch eyes, you can watch that thumb move back and forth. So your brain uses that angle difference to determine distances. We can do this in astronomy, except that instead you can look at an astronomical object from two very widely separated points on Earth, and they won't see it exactly the same way. There'll be a little bit of a shift. And so in 2012, we repeated an experiment that had been done several times previous, which is we were watching Venus cross in front of the Sun from our point of view. And people at very different places on Earth could look at where it was on the surface of the Sun, measure very accurately where it was, and you could actually use that information to figure out how far away the Sun was simply by using trigonometry at that point.
Yeah, but trigonometry is an illusion.
It's a very useful one. So yeah, that's sort of the way we basically, and the Greeks invented geometry, and when they did that, they weren't necessarily thinking about doing astronomy, but they realized that they could apply it to things around them. And being curious folks, the one fellow noticed that when the shadow went straight down a well, that if you moved several hundred miles away, it didn't do that anymore. And he used that angle information again to figure out that A, the Earth was round, and B, how big around it actually was. So that was sort of our first approximation size of the Earth determination. You can also watch the shadow of the Earth, faked or not, as it goes across the moon during a lunar eclipse. And you can watch the shadow of the moon as it across the Earth during a solar eclipse the same way. And we'll hopefully get a chance to do that here in 2017. The shape of the Earth is kind of an interesting thing. I remember hearing about it being egg-shaped, and technically, I mean, no object is perfectly round, but to your eye looking at it, it's going to look pretty round. It's a very small difference. So, and it's a little bit wider at the equator because it's spinning, although again, I don't know how you explain that. Well, you have to go into all that map making then for that. But as a sphere, it's a little bigger at the equator because it spins, and that tends to flatten it out at the poles a bit and bulge out the equator. So, but it's a very small difference that you wouldn't notice with just your eye.
But if we start questioning the Earth being spherical, then a lot of the other sciences start breaking down, and then we're left with very little to hold on to because of, from what I know, science depends on each other. Like the stuff that can be tested depends on each other. And Neil deGrasse Tyson has been attacked by the flat Earth conspiracists, saying that he blames the educational system in the U.S. for people believing in these things, and they say, oh, well, he's part of the conspiracy. So you also sent me a thing about even children being able to show the curvature of the Earth. Can you tell us about their experiment with weather balloons?
Yeah, there's a group in California. They actually make a little bit of money for themselves. They launch weather balloons, and they're sponsored. If you give them money, they'll launch just about whatever you want. The balloons go straight up for about 120,000 feet. They have a camera on the balloon, and so they take pictures of things that have been sent to space, and they take pictures then of the Earth from that altitude. It's pretty obviously curved. You get a very nice view from that height of the Earth itself. And then the balloon pops eventually, because as it goes up, it runs out of atmosphere. The helium expands and it eventually pops the balloon. At that point, it just comes straight back down on a parachute. They recover the payload, and so they've sent greeting cards to space and things like that. But they get very lovely pictures, and I'm pretty sure these kids are not part of a giant conspiracy. So it's hard to imagine how many people you might have to include till you would get everybody that might be responsible. I do think sometimes the education system, maybe because we're trying to do so much in so little time, they ask kids to simply believe whatever is told them, and they don't really get a chance to do any kind of hands-on experiment to find out for themselves. And so at some point people do get, maybe tired, or they have some reason to think that they should stop believing everything they've been told. And that's too bad, because really there are a lot of ways in which you can verify things for yourself. It might take a little time or effort, but people should know how we know things, not just what we know.
Tell us about the great eclipse that is coming up in 2017, and not only people from NASA are going to be documenting that, but you say anybody with a little bit of skill can map it as well?
Yes. The equations that govern the laws of motion as we know them are not that difficult. And there are a lot of people that really get interested in it and want to learn how to do the calculations. How do you figure out where and when an eclipse will happen? We've pretty much known the geometry of it for about 2,000 years. It's very, very easy to predict a lunar eclipse. And actually almost anybody, if you observe the moon, I would say for a year or so and watch its motion, you could probably figure out when the next lunar eclipse for you is going to happen. But those are very broad. The Earth throws actually a huge shadow into space, so to predict when the moon hits that shadow is pretty easy. The reverse, though, when the moon blocks out the sun, is harder because the moon throws a very small shadow, depending on exactly what its distance from us is at the time. This particular path will be only about 80 miles wide. And so it does this little narrow trek across the planet, and it will lift off the planet because eventually the curve of the Earth gets, curves away from the shadow, and then it's back into space again. But this particular path will cross the entire U.S. from Oregon to South Carolina. And so we're calling it the Great American Eclipse because it touches nothing but America. And almost anybody who wants to see it can see it. You can drive into the path yourself. Because of that, there are several enthusiasts who've really gotten interested in it. Michael Zeiler, who has a website called Great American Eclipse, is a professional map maker, and so he has been interested to do beautiful maps. Xavier Hubier, who's a French gentleman, has a very lovely interactive Google Maps site, and he himself does the calculations and takes a ridiculous amount of care. He chases eclipses, so he has a personal interest in getting it right, but they even take into account now the exact shape of the limb of the moon, how the mountains at that time are going to be to actually get you within fractional seconds of how long it will last for where you're at. But I'm really looking forward to it because at my house, it should be total for 2 minutes and 30 seconds. So I don't have to do anything but pull out a lawn chair that day and enjoy the show.
Wonderful. How did your daughter get involved with the Mars Science Laboratory data project?
Well, having a mom that's and my husband also, believe it or not, has a degree in astronomy. He does investments presently, but she got interested in geology. And geology is more fun when you do it on other planets. So she graduated with a degree in planetary geology and was fortunate enough to get into a graduate program at the Arizona State University, and so she works with the folks that are working with curiosity data. So, you know, it's a lot of fun. It's not every day you get an email from your kids saying, I got to tell the laser what to zap on Mars today. But she's finding out what Mars is made of, and that's really cool.
So what is this NASA JPL Solar System Ambassador Program like, and is that where they recruit you to teach the world the lies that they're trying to control them with?
That'd be fun, but no, they actually ask you simply to apply. They don't recruit actively. You have to apply, and you know, you give them some background why they should let you do this, and they actually just simply make a lot of information available to you. A lot of it is in the form of a webcast or hangouts with some of the scientists who are doing the work, and so then there's questions and answers where you can ask them about their work, and, you know, so that you can understand it well enough then to explain it to others. But they're looking for people that are not themselves maybe scientists, but can explain it in terms that ordinary people hopefully could understand.
So, according to techtimes.com, there are 10 things that people who believe in a flat Earth espouse, and I'm going to go down. We already touched some of them, but I'm going to go down the list and see what you think. They said that if the Earth were round, people on the bottom would fall off. But the second one is they don't believe in gravity. And to me, it's like, well, right there, like it's like a self-fulfilling prophecy or like a self-supportive statement. They think that the flat disk Earth is like flying upwards, and that's how people stay on it. But again, like why and like where are we going?
To do that, and Einstein actually said you can't tell the difference as to whether you're in a gravity field or whether you're in an accelerating elevator. But if we were on, that's the thing, it's not just, the Earth couldn't be just moving at a constant speed. That would not simulate gravity. It would actually have to be accelerating. Because when you drop a ball, it does not fall at a constant speed to the ground. It's going faster and faster and faster as it gets nearer the ground, so it's accelerating in its fall. So the Earth would have to be accelerating upward, and if it were doing that for thousands of years, by now we would be moving at such a tremendous speed that if you jumped up, the Earth would be smacking you in the feet before you could come back down. So that wouldn't work, I don't think, really well. Spherical objects that, you know, yeah, again, you do have to believe in gravity, but every place you are is down is at your feet, always. And so people in Australia don't fall off. But if you are in Australia and you look up at the sky, if you find a constellation that you can see from the northern hemisphere, you will notice that it's upside down. The moon is upside down from Australia. So you can tell that you're on the bottom, say, versus the top, and those are just arbitrary definitions. I'm sure Australia would much rather we called that the top. But, you know, we just defined one pole as north, and for whatever reason we conceive of north as up. But but it's really just arbitrary. If you had a beach ball and you didn't draw any lines on it, where would the North Pole be if that didn't have any pattern, didn't have an inflation hole that you could find? Up is whatever direction you're standing on. So it works so simply that it's hard to imagine why you would want to replace that with another model. All the ways we look at the world are models, but you try to choose the simplest model that fits all the facts you have and makes it work. Because I don't want to make it any more complicated than it has to be. But
then they'll say, oh, well, that's the thing. The world is even more complicated than we think, and that's why it's so amazing. And they feel that the scientists are trying to take away the awe of the universe, I guess. The next one is that Antarctica surrounds the Earth, and so there's a sheet of ice around the disk, and that shows, and they claim that no one's ever been to Antarctica. You have something to say about that?
Oh, well, plenty of people think they've actually crossed the entire continent. We have an observatory currently at the South Pole, so I don't know where those people are if they're not actually at the pole. Again, it would take some pretty complicated tomfoolery to make you think you're at the pole if you're not. You're going to look up at the night sky. You're going to have 6 months of darkness during the winter. And it's pretty obvious to watch the stars rotate that you're at the rotational pole. I think a lot of people, if they did a little bit more traveling too, would notice that it's really striking when you're far enough north to see the sun never set in the summertime that you're not looking at it the same way you were looking at it from home. But yeah, if you think then how big this flat disk is, there should be some point at which you could crank up a balloon or something and see Antarctica all the way around you. So it doesn't seem like that would be really hard to prove.
There's some that say that the flat thing keeps going forever, and so that's even more outrageous than I struggle with the idea that the universe is infinite, because there's no way to quantify that and to even picture it. So now you have an infinite Earth, and the next one is even crazier, where the sun circles around over the Earth. But when people have been challenged about that, they say, well, the sun is a projection and the moon is a projection. So next thing you know is like the Truman Show, where nothing is real and it's all government produced. So anything you can tell us about how we know for a fact that the Earth revolves around the sun?
Greeks understood, once they kind of understood the geometry, that it could work either way, that you could model it that we're in the center of the universe and everything goes around us, and that actually works fine even if you think the Earth is a sphere, or did we go around the sun? And to them, they said, well, if we're going around the sun, we have to be moving at such a rate to get the sun to come up and go down every 24 hours means that this latitude that you, me, and everything else would be moving at about 800 miles an hour. And we don't feel like we're moving at 800 miles an hour, so that seemed pretty outrageous, so they went with a static Earth. And that made total sense. As it is, everything is moving with us, and we don't have a sense of that motion. How to prove it? You can look at the sun. You can actually look at the sun. I have a nice solar telescope. I can watch prominences come and go. You can watch sunspots and watch the sun rotate. For somebody to simulate with a projection the sun doing all those things would take a whole lot of work. And yeah, I don't really know why you'd want to do that. Then you have to answer the question, well, what are stars? Because as far as the light goes, the sun and stars they're all the same. All the stars we see at night would look just like the sun if you could put them at the same distance. And even worse nowadays, and again, you have to believe that people aren't faking everything, but we can actually watch planets go around other stars. So moons go around Jupiter. That was Galileo's test, that he looked at that and said, well, if moons go around Jupiter, we go around the sun. And that's just the way it is. The fact that we rotate, you don't normally notice, but we notice it in weather systems. We notice it in the way that high and low pressure systems interact as they get caught up in that motion, because they're big enough that the spinning Earth affects them. And so you have things like hurricanes spinning one way in the northern hemisphere and the opposite way in the southern hemisphere. And that's due to Coriolis effect, which is something you don't see unless you're in a rotating reference frame. So there's so many things that work if you just assume we're on a ball and it rotates, and then that all hangs together in a very consistent way Whereas if you're doing anything else, you're going to have to invent all these people to take care of all these things that you see. And okay, today I could say we got, technology and a big government. Maybe you could believe, but what were the, ancient Egyptians looking at? Who was making all that happen for them? Because they experienced the same sky, the same motions, things like that.
Yeah, but those were the aliens guiding them, and that's a different show.
Yeah, that's the alien show. And I mean, you can't refute sort of arguments like that too far, because you can reduce it to, well, I was created 5 minutes ago with all of my memories and thoughts intact, and okay. But that's not very interesting, I don't think.
Well, it's not provable. Anybody can believe whatever they want, but there's no way for us to be accountable to each other on where we're at in this life.
But you can look out, you can do, again, you can look out, you can look at the way things move, you can look at I don't even know how the flat earth people actually account for the phases of the moon all that well, except, again, just wave your hand and say it's a projection. Because otherwise, again, it works very nicely with the moon just having day and night just like we do. It just depends on what angle the sun, earth, and moon are making. But you can look out at night, and on a good, clear night, which we don't really get much of, Middle Tennessee is plagued by light pollution almost everywhere. There is a nice fuzzy blot that you can see in the fall sky. If we could see what cameras see, it would cover twice the width of the full moon in the sky, and it's the Andromeda Galaxy. I would tell you it's our nearest neighbor galaxy in space, a huge pinwheel of stars, much like our own Milky Way, and it's visible to the naked eye. And we can measure without a whole lot of difficulty. Again, you gotta believe in trigonometry, but that's about it. But you can measure the distance to that galaxy, and it's over 2 million light years away. I think it's kind of cool to look up and think about how that light has made that long journey just to come all the way down to my eye. I really don't find science as reducing the awe, the wonder, the intricate dance that the planets make with each other. Because even though for gravity you can write the equations down for two bodies, once you get out of that realm, you can no longer write a single equation that describes, say, the solar system. And if we didn't have computers, we would never be able to fly spacecraft. And I assure you that the scientists believe that they are flying spacecraft, like to Jupiter right now. And either they're deluded or part of the conspiracy, because usually they built the instruments themselves and put them on the spacecraft, and they're getting back the data. So it's just really confounding how many people you'd have to have in a conspiracy like that, and they would all have to agree to it. Very few things in this planet are secret unless only one or two people know them, let alone hundreds of thousands of people. So I don't know what you get for believing that, really.
No, all you gotta do is watch a documentary on how difficult it is to get stuff up into space, like trying to get a rover into Mars, like all the work that goes into it. It's just amazing, what humans can do, but also how difficult it is, and how limited we are, but we're still trying.
We crashed 2/3 of everything we sent to Mars. We crashed it. So lately we've had a pretty good track record, but, it is hard. But it's so darn cool that you want to do it anyway, so I think you want to do it anyway. That would just be me, but...
Well, the next 3 points of belief, we already discussed. The edges of the Earth are too inhospitable for nearly anyone to go there. This thing about nobody's been to Antarctica. Astronauts know the Earth is flat, but they're playing along with the gimmick. The 7th one, no one knows what's on the other side of the flat Earth, or if there is another side or not. And that's the one where the Earth might be endless. So, I don't see any point on discussing that. But
yeah, it's turtles all the way down. I mean, that's a tough question. I mean, that was the ancients' view, because, again, to most of us, if you're standing on the Earth, it looks flat. That's our first model of the universe in our own brains is I'm standing on a flat plane, and the Earth is a big bowl over my head, or the sky, rather, is a huge bowl over my head, and that's what it looks like. And you can actually get pretty far with just that model. And if you never had to travel far, if you never had to sail across an ocean, if you never had to pilot an airplane, say, across an ocean and actually arrive at where you wanted to, you could do fine with a flat Earth. But to do almost anything that's going to involve distance on this planet, you should have a model that involves it being around Earth, or you're not going to get where you think you're going to get.
And when they quote religious texts to support their view, they were saying different things than what scientists are looking for. They were looking for a meaning. They were looking for connection to the gods or God, and trying to make sense of the universe at that time for those reasons. So we're speaking different languages. We're talking about stuff that is verifiable, stuff that helps with the mechanics of civilization. And like you said, there was pretty advanced civilizations in the past that were able to map the stars, that were able to get a sense of the universe, maybe limited, but they still were working within some of the same parameters.
Yep. And in fact, interestingly, even the Greeks, one of the things they did know, because they had records going back through the Egyptians, was that the stars were moving. They were shifting in kind of an odd way. And in fact, since again they were modeling it with the sky turning rather than the Earth turning, but it's just a reflection. So in geometry, it really doesn't matter. The Egyptians, when they built the pyramids, they wanted to have a shaft that pointed toward the North Star because that was important in their religious beliefs. That was how the pharaoh's soul was going to get to that part of the sky where he needed to be. Well, that star is not the same star that we today call the North Star because the pole of the Earth precesses. Just like a spinning top, when you set it down, it'll go straight for a little while, and then after a while it's doing a thing where the top of it describes a circle. The Earth does that. And it takes thousands of years for it to make that complete circle. But today we call the end of the handle of the Little Dipper Polaris the North Star, but they call the star in Draco the Dragon the North Star because it's shifted that far over those thousands of years. And people actually started to notice that, which is kind of interesting, that their observations were good. They were doing good science. They were making good maps of the night sky. Today most people can't find their way around the night sky, which is kind of interesting. I do think it's nice for people to do that, though, because I would argue that there is a connection from us to the rest of the universe, and it is important to feel that. I like seeing the rhythm of the seasons, watching the patterns in the sky as they come and go with the seasons. I really enjoy watching that, and I do think it makes you connected to the rest of the universe. I know Neil deGrasse Tyson made a big deal out of it. It's also kind of cool that most of the atoms that we're made of, we believe, were created in stars. When the universe began, it was not much other than hydrogen and helium. And stars are the fusion furnaces of the universe. They put together all the rest of the elements, and then they give them back to the universe when they blow up. So supernovas create elements, scatter them out, and we're built of those elements. So we're made of things that were once inside of stars. So I've always thought that that's extremely cool. And again, it's not a just so story that somebody thought sounded good. Back in the 50s when we started trying to understand fusion and that it played such a role in stars, somebody said, what if I took in a universe made of nothing but hydrogen and helium, and we know how many stars a year roughly are formed, we know how many blow up, what if I took that, ran it through however long we think the universe has been around, what would be the elements that we would see today in what percentages? And when you do that, interestingly, you come out with pretty much what we see. And so that's... Scientists aren't trying to make things up just to either diss religion or tell funny stories. They're actually trying to find a coherent tale that in the simplest way we can explains everything we see, all the data that we can find. And in many ways, it's a very beautiful story. I had a professor who was talking about the orbits of the planets, and he said, you can write that as a harmonic Anyway, you can write it out as an equation that's exactly as music would be. It is literally the music of the spheres. It's kind of beautiful the way everything interacts. So I don't find it mechanical or necessarily just really sterile or anything. One of the Hubble scientists said, we expected to do great science with Hubble. What we didn't expect was the beauty. And most people find the Hubble images to be ridiculously pretty. So I don't find that it takes away from the wonder.
Definitely. The other three aspects of their belief has to do with the other planets being flat, but as I read about it, it doesn't even make any sense. They say that they're like little discs that are flying up in the sky and this and that. The ninth one is that satellites are towers, and what I've heard is that the towers are trying to control the people and all the stuff. And then the last one is that they trust their own senses above scientific inquiry the way that we know it. So you mentioned that observation is the way that the ancients were able to decipher some of these things, and observation is what keeps science going because we trust our senses, and then we have to figure out ways to measure them and test our findings. So just going by our whims and saying, well, it would be nice if the earth was flat, or I'm going to find someone who believes that the earth is flat, who's anti-establishment, and I'm going to follow that person. It just, to me, just goes back to being accountable to one another and having a group of people that you can relate to. So I see the scientists as a unified like group of observers, of people who are researching the cosmos to get a greater understanding of it. And in a lot of ways, that's what religion and spirituality has had as its principle, is trying to connect with everything that surrounds us. So it doesn't have to be either or, and it doesn't have to be that the people who are into flat Earth are a little more enlightened because they're not bound by science or by the establishment. Do you know any like rogue scientists that are being persecuted for their findings or not accepted at this time that you can share?
There are always a few, because there are dissenting points of view, and you have to argue really hard for some. I would say there was a gentleman a while back that was making the claim that a particular asteroid that was found, not asteroid, it's a meteorite when it falls down, and it was found in Antarctica. His claim was that there were things inside that when they took a slice of it that looked like microbes, and that this particular piece of rock had actually come from Mars, and he argued that this was evidence for life on Mars. Now that's a very extraordinary claim, and so when you make a claim like that, other scientists are going to be really hard on you, and they were really hard on this guy. I think the jury is still really open on that point, but, most people were not convinced. It was not convincing enough. But if somebody else comes up with something similar and says, okay, here's another one, or here's another example, and maybe it's a better one, then people will look at it. There's a pretty famous example, the lady is getting old too. Vera Rubin was a scientist, and when she was doing her doctoral work, she was looking at galaxies and how fast they rotate. And they weren't, the rotation rates were not what you should expect from using the normal Newtonian laws of motion. And she said there must be something there that we're not seeing, because that's the only way you could get this to work. And she was almost laughed out of the room when she presented that. Today, her ideas are generally thought to be correct, and people would really like to see her given a Nobel Prize before she dies. But, it does happen in science that people will advance an idea, they get really grilled on it, but again, once observations pile up enough, people will give up whatever their prejudice was and say, okay, I have to give up this point of view because it's clearly not right. You've got the data to support what you're trying to do. String theorists right now, you'll hear sometimes people talk about string theory. They're considered pretty fringe because none of the ideas they have are testable. And so they need to come up with a testable idea because you can't do science if it's not testable. So they're kind of considered fringe and a little bit wacko, but that doesn't stop them. So that's a good thing.
Here where we live, environmentalism is a big thing. So do you have anything to share about the other conspiracy theory that there is no climate change, that there is no way humans have affected the world through pollution. Can you share a couple of examples of how we know that it is happening?
Well, we can measure how much carbon we're putting into the atmosphere every year, and it's a pretty big number. It's, I think, right now running something around 100 times what volcanoes and other sort of natural things put in. So we're adding a tremendous amount of carbon as CO2 to the atmosphere. CO2 is an efficient trapper of heat. So it's hard to imagine that we could keep on doing that forever and not see an effect. I think the debate is going to be about how much effect. Even for scientists, you draw the line, you say if this goes on forever, then we're doomed. And generally, whatever it is, doesn't go on forever. But we're definitely impacting the environment. Here in Middle Tennessee, we're actually in a very sweet spot. I have another son that's studying meteorology, and I jazz him about this. Our climate here in Middle Tennessee has changed extremely little. We really are not seeing global warming. Other places are seeing it a little bit harder than we are, and sometimes it's subtle things. There are beetles that are eating trees across the west that are able to shift where they live just a little bit every winter, and there are vast forests that are being chewed up by these guys. Now, eventually, either something will eat them because they're going to be an available food source. The environment will bring it back into balance, but it might take a while. But there are small, subtle changes that say that, yes, there is an impact. Can you argue that it's all natural? You can try. But again, when we're doing such a lot on our own, nature is probably contributing some as well, but nature could also be trying to cool the planet into the next ice age, and we're cheerfully warming it up too. What you don't want to happen is for change to happen at a pace that neither we nor the rest of the environment can deal with easily. So you don't want to really run the world's biggest science experiment ever and have it go awry. I mean, that's kind of what we're doing right now. Is let's see if we can change our environment. People have ruined it on a small scale. If you've ever gone up to Sudbury, Ontario, they had a big smelter up there. It's a big iron deposit. And they put so much sulfur oxides into the air that it fell back basically as acid rain in the vicinity, and the granite rock up there has very little soil to begin with. So they killed every tree for miles around. It looks like a moonscape. And it will be a very long time before it looks like anything else again. So we can change it on the small scale, and we can probably change it on the big scale. And we won't know how good we're doing until we kind of run out of the environment's buffers. You can keep stuffing a lot of CO2 into the ocean, but at some point it'll be saturated and it won't take anymore. There is a planet next to us that's got an unfortunate amount of CO2 in the atmosphere, and that's Venus. And Venus is 800 degrees day and night on all the way around the planet. We can't, I don't think, do that, but you definitely don't want to go there. But in any case, what we're doing when we're putting CO2, we're polluting. And so if we don't have to do that, we probably should not do that. Leave no trace is a great way to camp. It's a great way to treat your whole planet. We put light into the night sky. Astronomers complain about it for no reason. That's all wasted light. It doesn't help you see at night. It just goes up into space. It's a complete waste of energy and money. So why should we do that? Why not instead use our resources wisely so that if nothing else, they would last for more generations? Give some to your kids to live on when they're in our place, and simply not pollute. But like I said, it's the biggest science experiment ever. So I think you'd be well advised to err on the side of caution rather than seeing how far we can push it.
So I know the next topic is more psychology than your type of science, but the reason that I'm not interviewing one of the other guests on the show or the previous interviews that I'm going to play is that the theologian who started debating other Christians about the earth being flat has been bombarded by nasty emails, and like his server and his website and stuff like that has been completely covered by people that have a lot of spare time. to the point where you can't even catch him anymore because he's fighting off conspiracy theorists left and right. And I hope that doesn't happen to you or me discussing this topic. But this idea of there's only so many hours in the day to explore the world or to talk about interesting subjects. Do you have any? Is there such a thing as bullying from the scientific community? Like, if you are, part of NASA or exploring something, that has anybody ever come across people where they like shut you down because they don't like what you're saying? Or have you ever had that problem with six-day creationists or people that don't want science to be taught in schools, or they don't want their kids to come to the planetarium or things like that? Is that common around here?
You get some of it. I mean, we get some pushback. We had people who would ask for programs specifically asking that they not talk about the age of the Earth or anything like that. They did not want the children to hear that, which, I mean, that's fine. At some point, they're going to hear it. If you can, if you have a particular viewpoint and you should be able to defend it well enough that that's not a problem. But it's a shame that people get really virulent. Because there is room for all viewpoints. And again, you can put your viewpoint out there, see if you can support it, and then just go with what you want to believe. So there's no reason to get hostile or angry or, to be ugly to people. Sometimes people, especially scientists, will make, I think, the mistake of thinking that people that think otherwise are stupid, and they will more or less verbalize that, which then antagonizes the other side, and then they quit listening. So there is a certain amount of intolerance that comes around, but generally people have been pretty good. They'll just say, well, that's just not what I believe, and I'm okay with that. If you're an adult, you've looked at it, and in your head this is what you want to believe, I'm fine with that. I'm not going to call you stupid or ignorant or anything else. So people should be tolerant of each other's viewpoints, and hopefully, I don't know why so many people have nothing better to do than to attack people and just be generally ugly. Go outside and look at the sky instead.
Do you get frustrated like I do when you watch, some of these so-called science channels or history channels or whatever, when they talk about religion, having a master's in religion, I get very frustrated because they'll say things that are not true or push very fringe ideas to get ratings. Do you see that happening with science as well? I know that some people complain about their depiction of sharks or just exploiting scientific stuff to get ratings. Have you experienced that lately?
The Discovery, some of those channels go pretty far off the rails to try to get ratings. The History Channel, you would think the Nazis were absolute geniuses, and I don't know why they didn't take over the world, because they had all this cool stuff that nobody knows about. But so there's a lot of that. There's a lot of unsubstantiated things. One of my kids was really disappointed because he watched the One Shark show and was disappointed to find out that it was really a faux documentary. They had made it as if it were real, even though it wasn't. And they would just give a little disclaimer at the beginning and end saying, oh, this is just a fake documentary, but people watching it didn't really get that. And so then you end up having to, have people ask you about it, and you have to say, no, that actually wasn't true, sorry. So that's very frustrating because they could be putting out better information, and it's just as interesting, so I don't know why they want to push things. But, it'll be the Loch Ness Monster, it'll be Bigfoot, it'll be whatever thing that you can't actually find or verify that they're going to run with because, I don't know, people find it interesting. People do like unexplained mysteries, and so that's always a hook, but a lot of times they do run off the deep end. I think one of them did something on mermaids not too long ago that was really odd, but sharks are interesting in and of themselves. You don't have to make them something they're not.
Yeah, and the other guest that we're going to feature in the interview, he does scientific research, and he's been asked to debate people about different topics, and there was a point where he decided not to debate anymore because by debating, you're saying that both options are equally feasible, and when you're dealing with science and creationism or some other random conspiracy, you're giving them a lot of you're giving them a stage, and you're giving them a lot of forget the word attention, and putting them on an equal plane. Do you feel like that about some subjects, or like you said, if people have something to back it up, we need to give them an opportunity to share their thoughts? Or
I mean, you can share your thoughts, but then at some point, if what you're teaching is just absolutely not supported by any fact or observation, you can't pretend it is. There was actually a discussion at a workshop I went to recently, because there will be a lot of misinformation about eclipses. For example, there is a certain body of folk knowledge that says it's harmful to babies for the mom to even be outdoors, that somehow there are harmful rays during an eclipse. And there's not. It's just the same sun and moon they always are. But so they wanted to know, should we mention those ideas? And the feeling was no. It's better just to put out correct information and to not even cite the incorrect, because, by doing that, you lend a little bit of credence to it, or you put it in somebody's mind that it was never in before. So you're better off just putting out correct information as best you can, and as best you know, and, not talk about other things. But I mean, we get asked, I get asked, usually in a joking way, at a star party. We're looking at the moon, and they'll ask me if I can show them the flag. Well, I can't. It's too small. From Earth, you cannot see that. But people will kind of poke around the edges to find out, what you think or whatever. I get asked a lot about UFOs. And generally, if you spend a lot of time out under the sky, you don't see them. But typically on a night, we'll try to observe. You mentioned satellites. It's always fun when we have an overflight of the ISS. You can see that easily with your eyes. And you can actually, there's a gentleman in France, go look up some of his amazing work. His name is Thierry, Thierry Legault, Legault. He actually takes pictures from his backyard in France of the ISS, and you can see the entire space station. He just does them. He can see it when they're docked up there, and see when the guy is outside. So it's just amazing what he can do. So we try to show people as much as we can, and let them know that, because so many people don't ever go outside and look up, that there are some really cool things you can see with just your eyes. So hopefully we address some of their concerns or some of the things that they've heard, because, the internet puts things everywhere. But I try not to debate.
Just real quick, what is a star party again?
We set up at a park, and we bring telescopes, set them up, and then everybody gets to look. And on a good night, we'll have 8 or 10 telescopes, hopefully all looking at different things. We don't actually coordinate that. It just works pretty well, generally letting people look at what they want to. But we'll look at the moon. Right now we have both Jupiter and Saturn in the sky. And if you want to talk about something that does actually look like you're faking it, it's Saturn, because it looks ridiculous with the rings. So we'll look at some of, whatever bright planets we have and a few deep sky objects. And we just let everybody look, because so many people have never had the chance to look through a telescope and see these things. And so it's kind of fun to do it. I usually am just looking at the moon. I have a small telescope. I'll put it on the moon, and it's really, really rewarding to have little kids come up and look at the moon and just go, that's the coolest thing I've ever seen. And they're just amazed and astonished that you can see the craters so well. And it's a lot of fun to share that view with people. So we do that about once a month, weather permitting. So, for example, we'll be at Warner Park on Saturday night if we don't get clouded out. In the Nashville area, we get a lot of requests from elsewhere, but we just don't have enough people to literally go around and do all that. But it's a tremendous amount of fun, so if anybody gets a chance, they should come on out.
Wonderful. Thanks again for being on the show. Well, if you have anything you'd like to share with us on the show, or you have friends that you would like for us to interview regarding anything related with science, we would love to have them. In the intro, we say we explore all topics related to scientific, conspiratorial, philosophical, blah, blah, blah. And this is like the first scientific show we've done other than trying to debunk other conspiracies. So we would love to keep exploring things related to the universe and just educate people about what's out there. And it's great to know about your organization.
Okay, thanks.
Thank you for listening. We will be back next week with another episode of The Mystic and the Skeptic.
Show descriptions and content are available online on our Facebook page and on SoundCloud.com.